Next topic is 2 PDA. 2 PDA means 2 stack push down automata. So what is a push down automata? So you know that according to Chomsky hierarchy, you have different types of grammars, right? Regular grammar, okay, context free grammar, context sensitive grammar, unrestricted grammar. Regular grammars generate regular languages and the machine is finite automata. Context free grammars generate context free languages accepted by machine push down automata, right? Context sensitive grammar generates context sensitive language, machine is linear bounded automata. And unrestricted grammar which are a recursively enumerable language and the corresponding machine is Turing machine. This is regular language and the machine is finite automata or finite state machine. Okay, so this is type 0 grammar, this is type 1 grammar, type 2 grammar, type 3 grammar. So type 2 grammars are known as context free grammar which generates context free languages, okay, CFL, and the machine which accept all the context free languages are nothing but push down automata. So what is a push down automata? Push down automata is a finite automata with a stack, okay, single stack. Okay. So a typical push down automata has a state machine along with a single stack. It recognizes a language which is context free languages. Suppose if you are adding a second stack, it become more powerful. Okay, so along with the finite automata, we are using a stack. This is a push down automata. If we are adding two stacks, then it will be more powerful compared to a single push down automata. Okay. So if you add a second stack, if you add one more stack, it becomes more powerful. Actually, it has the same power as Turing machine, and a Turing machine can be built to compute anything that is computable. Okay. So a two-stack push-down automata, otherwise known as 2 PDA, is a theoretical computational model that extends the concept of normal push-down automata by utilizing two stacks instead of one. Okay, in normal push down automata we are using only single stack, but in case of two stack push down automata, we are using two stacks instead of one. This enhancement allows 2 PDA to recognize a broader class of languages, especially context free languages and some context sensitive language. So 2 push down automata can recognize context free languages as well as some context sensitive languages. A single PDA can recognize only context free languages, but a 2 PDA is more powerful than that of normal PDA. So this will recognize context free languages as well as some context sensitive languages. Okay, so if we are taking the state like a standard PDA, a 2 PDA consists of finite number of states including start state. So it contains a start state and one or more accepting state, final state. Okay, and if we are considering the number of stack, a 2 PDA contains two stacks which can be used to store symbols. Each stack can be manipulated. So there will be two stack. This is stack 1, this is stack 2. Okay, each stack can be manipulated independently. Each stack is manipulated independently. And if you are considering the transition function, then Q cross state on a particular input symbol, then what is the we are in push down automata, we are using stack. Okay, so it contains stack alphabet. So to1, here we are using two stacks. So to1 cross to2 gives Q cross to1 star cross to2 star. This is the transition function of 2 PDA. Normal PDA, Q cross sigma cross to equal to Q cross sigma to star. Here we are using two stacks. So this is for first stack, this is for the second stack. Okay, so this is the transition function of 2 PDA. What is Q here? Q is the set of state, sigma is the input alphabet, and to1 and to2 are the stack alphabet. So these two are stack alphabet. So how the input is processing in 2 PDA? The 2 PDA reads an input symbol and can perform the following action. Okay, so we are using two stacks, stack 1 and stack 2. So we can push a symbol onto one or both stacks. We can perform push operation to this stack or both. Also we can perform pop operation, and also we can change the state based on the current state input symbol and the symbol at the top of the stack. Okay, so mainly two operations, push and pop, in both, either or both of the stacks. So when you can say a push down automata is accepted a string, a push down automata can accept a string either it reach the final state or when the stack is empty. So a 2 PDA, in case of 2 PDA, a string is said to be accepted. A string is said to be accepted either it reaches the final state or both stacks become empty. Okay, in case of 2 PDA. So this is the acceptance case of 2 PDA. And the application for 2 PDAs, we are using it for parsing. That is, a 2 PDA can be used in parsing algorithm for some programming languages, particularly those requiring more complex language construct. Also, we can use in theoretical computation science, that is TOC, that is the serve as a tool for studying the limit of computation and the relationship between different classes of languages, context-free language, context-sensitive languages, etc. Okay, so in TOC we are using, and in compiler design we are using. In compiler design for parsing also we are using 2 PDA. So 2 PDA is nothing but here we are, instead of single stack we are using two stacks here, and we can perform push operation and pop operation in both stacks, and it is more powerful than the single PDA, okay, normal PDA, because this PDA can recognize only context-free languages, okay, only context-free languages, but 2 PDA is more powerful than normal PDA. It can recognize all the context-free languages as well as some context-sensitive languages. And the transition function is, we are using two stacks, so we are using two tape or stack alpha, not tape, two stack alphabets, to1 and to2. So this is the transition function for 2 PDA. Okay, and we are using this in parsing as well as in TOC, okay, for comparing different languages. Let's see one example how 2 PDA can recognize a particular language. So here we already know this is a context sensitive language, right? L equal to a power n such that n greater than or equal to 1 or 0. This is a regular language. L equal to a power n b power n such that n greater than or equal to 1 or 0. This is context free languages. Okay, a power n, b power n, c power n. This is context sensitive language. This is regular language. This is context free language. This is context sensitive language. So I already told you, by using 2 PDA, the 2 PDA is more powerful than normal PDA. Normal PDA will recognize only context free languages, but 2 PDA can recognize context free languages as well as some context sensitive language. Okay, so we are taking this example here. So in 2 PDA we are using two stacks, S1 as well as S2. Okay, so for showing this I am taking one example, A, B, B, C, C. A power n, that is A square, B square, C square. A power n, B power, here n is equal to 2. Okay, so 2A, 2B, 2C. Okay, so the logic here is, so here we are using two stacks because we are using 2 PDA. So 2 PDA consists of two stacks. So for stack 1, the top of the stack is set 0. We are pushing set 0 to the top of the stack, and here it is set 1. The top of the stack for stack S2 is set 1. The top of the stack for stack S1 is set 0. Okay, so this is the top of the stack. Now our logic is, so whenever I am seeing A, okay, whenever I am seeing A, I am pushing A to the stack S1. I am going to say the logic, how it is going to work. Okay, whenever I am seeing A, I am pushing A to stack S1. Whenever I am seeing B, I am popping A from S1 as well as pushing B to stack S2. Okay, whenever I am seeing the symbol C, just I am popping B from stack S2. So this is my logic. Okay, whenever we are reading the input symbol A, we are pushing A to the stack S1. Whenever I am seeing the input symbol B, I am popping A from S1 and pushing B to S2. Whenever I am seeing C, I am popping B from S2. So let's see. So our input symbol is AAA, input string is AABBCC. So it is pointing A first. So whenever I am seeing, so this is stack 1, this is stack 2. Okay, so here the top of the stack is set 0, here it is set 1. So whenever the input symbol is A, what I need to do? I need to push A to stack S1. So I am pushing A to stack S1. Okay, now top points to this one. Again the input symbol we need to read is A. Whenever I am seeing A, I need to push A to stack. Okay, next input symbol is B. Whenever seeing B, so this is top, right? Whenever I am seeing the input symbol B, I need to perform two operations. What? Whenever I am seeing input symbol B, I need to pop A from the top of the stack S1 and I need to push B to stack S2. Okay, so whenever I am seeing B, I am popping A from stack S1 and I am pushing B to stack S2. Again symbol B, whenever I am seeing B, I need to pop A from stack S1, I need to push input symbol B to stack S2. Okay, then whenever I am seeing C, I need to pop B from S2. So I am popping B from S2. Whenever I am seeing next C also, I am popping B from stack S2. So now here you can see the stack contains only the set 0 and set 1. Okay, after that we are popping the top of the stack also. Now the stack S1 and S2 become empty. So we can say both stacks become empty. So we can say this particular string is accepted by the 2 PDA. Okay, so the only logic is whenever seeing A, at that time we need to push A to first stack. Whenever seeing B, we need to pop A from first stack and push B to second stack. Whenever seeing C, pop B from second stack. So this is a logic. Okay, so this is how a push down automata 2 PDA will work for this particular input string. So this string is accepted by the 2 PDA because we got the empty stack. Understood? Now how to draw the transition diagram? See, first state Q naught. Okay, whenever I am seeing A, so initially what we need to do, just assume that set 0 in S1 and set 1 in S2. Okay, then whenever I am seeing A, what I need to do, I am not popping anything. So in PDA, how to draw the transition? Input symbol, comma, pop bar push or pop hyphen push. Right? So input symbol, whenever I am seeing the input symbol A, that I am not popping anything. Already stack top contains set 0. Then what I need to do? I need to push A to the stack. So first A, whenever I am seeing first A, I am pushing A to the stack. So the stack contain A and set 0. Right? And what about second stack? So you need to represent, this is the first stack. We need to represent second stack also. Set 1. So set 1 is in the top of the stack for S2 and we are not doing anything. Okay, we are not popping anything, we are not pushing anything. So already stack contains set 1 only. Then whenever I am, so next A, whenever I am seeing next A, I need to push A to the stack. So if I am seeing A, what I need to do? I need to push A to the stack. Okay, so now the top of the stack contains, this is the top of the stack now. Before pushing second A, the top of the stack is A. So this is the top of the stack. Okay, A, then a stack contains, after pushing A, the stack contains two symbols A. Okay, and we are not doing anything for the second stack. Okay, so this is repeating. Whenever I am seeing A, initially the stack contains set 0, top of the stack contains set 0. We are adding A to the, we are pushing A to the stack and we are not doing anything for the second stack. Again, if I am seeing A, the top of the stack now is A and I am pushing A to the stack. Earlier this is the top of the stack, now we added A to the stack. Now this is currently this is the top of the stack. So A. Okay, and we are not doing anything for the second stack. Then what is the next? Whenever I am seeing a B, what I need to do? Whenever I am seeing a B, I am not doing anything. Not doing anything. I am popping, whenever I am seeing B, I am popping A from this first stack. I am popping A from the first stack without pushing anything. Okay, then so whenever I am seeing B, I am popping A from the stack and pushing B to the stack S2. Okay, so this is for the first stack. Whenever I am seeing B, I am popping A without pushing anything. And for second stack, okay, now the second stack contains Z1 is the top of the stack. What I need to do, I am pushing B to the stack. Okay, whenever I am seeing B, I am popping A from first stack and pushing B to the second stack. So B, I am pushing, earlier Z1 is the top of the stack. So now stack contains B and Z1 for the first B. Okay, then I need to repeat the things. Whenever we are seeing B, what I need to do, I am popping A from the first stack and I am pushing B to the second stack. Okay, then what I need to do when I am seeing C, whenever I am seeing a C, what I need to do, I am not doing anything for the first stack. I am just popping. Whenever I am seeing C, I am popping. First stack will be empty, only set 0 that contains. Okay, then whenever I am seeing C, I am popping B from the second stack. So how to write? I am popping B from the second stack without pushing anything. Okay, so this is stack 1, this is stack 2, this is input symbol. Okay, and I need to repeat whenever I am seeing C. So whenever I am seeing C, for first stack I am not doing anything. For second stack I am just popping B without pushing anything. Okay, then finally the stack contains only set 0 and set 1. Okay, stack S1 contains set 0 and stack to S2 contains set 1 only. So without seeing any input symbol, I need to pop all set 0 from stack 1 and I need to pop out all set 1 from stack 2, and thereby we reaching the final state. Okay, so this is the transition diagram. So initially we need to push set 0 also to the top of set 0 and set 1 to the top of the stack. Okay, that also you need to write. So whenever without seeing any input symbol, what I need to do, I need to pop nothing. I need to push set 0 to the first stack. Also I need to pop nothing to the second stack. I need to push set 1 to the second stack. Okay, so this is the Q0, this is the Q1, this is the Q2, this is the Q3, and this is the Q4. So this is how we are drawing the transition diagram for 2 PDA.